Scientific notation. Scientific notation is can't underline enough also how important this is. Scientific notation is used across a broad spectrum of different fields. Whether it's insurance or healthcare or anything in biology, chemistry, physics, astronomy. I mean, in so many different fields. And the reason for that is that measurements can get really, really small or they can get really, really big. And so you're dealing with numbers that are really small or really big. And scientific notation is a way of abbreviating or condensing that down into a manageable form, manageable size, so you can work with it, so it can be worked with. So I've got a couple of examples. So scientific measurements can get really small. For example, solid iron. So if you had a chunk of iron in your hand, iron atoms arrange themselves in a body-centered cubic unit cell. So the iron atoms are centered at all 8 corners of a cube and one at the center. So, here's a corner atom, corner, corner, corner. Here's one in the back, here's one in the front. And then we've got this iron atom here at the center of the cube. Now these are atoms, so this is a really small space, really small size. The distance between the centers of corner atoms is 0.0000000002886 meters. So the distance from the center of this atom to the center of this atom is that many meters. So this is an example of a really small number. And so if you were doing some mathematical calculations with it, you'd have to write down all those zeros, okay, and keep track of them. And that's where a lot of errors can happen. So instead of working with a long decimal number, we can write it in scientific notation. So instead of writing all of this out, we can just say that it's 2.886 times 10 to the negative 10 meters. So this is a much more manageable number to work with than that one. And scientific measurements can get really, really large. So the average distance between the sun and the earth is 149,597,870,700 meters. It's a really large number. So in scientific notation, that is equal to 1.49597870,700 times 10 to the 11 meters. Now that still is a lot of numbers, but being able to say times 10 to the 11 or times 10 to the 12 is really makes it easy to do calculations later. So scientific notation makes extremely small and large numbers more compact, easier to understand and to manipulate. So you'll notice that between these two examples that I just gave you, some commonalities is that, we have a number out in front, okay, that's between 0 and 10, multiplied times some power of 10 after it. In this first one, the power of 10 was a negative number, and here the power of 10 was a positive number. So this is the format for scientific notation. And here officially is kind of what it looks like. So we have a times 10 to the b power, where a is a coefficient. It's a decimal number between 1 and 10, not including 10. And b is the exponent, which is positive or negative integer or 0. So, here b was negative 10, so that was a negative integer. And here b was a positive integer, or positive 11. Now some calculators have trouble expressing b as a superscript of 10. So a lot of calculators have a hard time kind of representing this part of scientific notation. So instead, an E is used to substitute for the base of 10 down here. So here on the left, this is the screen of a TI-84 Plus CE calculator. And so you can see I entered in the distance between two iron atoms in BCC iron, and it took that number and it converted it into scientific notation. And so notice here that instead of using 10 to the minus 10 meters, it replaced that base of 10 with an E. Okay, it kept the minus 10 here, but this letter E, it substituted for a base 10. Okay, and then you can see here in this average distance between the sun and the earth, it converted it also to scientific notation. And instead of having this base 10 here, 10 to the 11 power, it substituted for 10, this capital E. Okay. So the reason why I'm leaning heavy on this is because a lot of my students in like pre-calculus and statistics, for example, aren't really clear what this means. And so they kind of ignore it and just look at this part of the number. Of course, if you ignore this back part of scientific notation, you're going to be off by a lot if all you did was pay attention to these numbers here. So that's why I'm leaning in heavy on scientific notation. So this is what it looks like on the TI-84 Plus CE calculator. I also use the NumWorks calculator, and I had entered this number in the NumWorks calculator, and you can see it represents scientific notation with that capital letter E also. And here's the average distance between the sun and Earth. And you can see it did it in scientific notation, but it used that uppercase E to represent base 10. So, because this is how calculators function, and because it's used in just about any area of science or mathematics that you can imagine, this is a really important topic to talk about and make sure that you understand. So like I said, it's extremely important not to ignore the integer following the E in your calculator. Okay, so let's move on. So on this page, I just kind of reiterated the equation for scientific notation, the format for scientific notation. And these were the two examples that I gave from the previous page. So you can see here that B, which is the exponent, was a negative number, negative integer, that was negative 10. And when you've got a negative integer, a negative exponent, the decimal point is going to move 10 decimal places. And here, since B is 11, the decimal point is going to move 11 decimal places. But we're going to talk about here is what do you do when the exponent is negative, positive? So that's what I mean by the sign of B. So the sign of B controls whether you're going to move the decimal point to the left or to the right. So the direction the decimal point moves correlates with the sign of B, where positive and negative numbers are found on the number line. So here I've just got a real basic number line with 0 here in the middle, and relative to 0, negative integers are to the left of 0 and positive integers are to the right. And so similarly, if your exponent B is a negative integer, then you're going to move the decimal point to the left. And if your exponent in scientific notation is a positive integer, then you're going to move the decimal point to the right. So you can kind of use the configuration of integers on a number line to kind of help you determine or remember whether you're moving the decimal place to the left or to the right. So let's look at some examples. So this first example, convert scientific notation to a decimal number. So here we've got 2.886 times 10 to the minus 10. So we're going to write 2.886. And because it says 10 to the minus 10, So B is -10. This negative means we're going to move the decimal point to the left 10 times. So here it is. Let me use a different color. So starting here, we're going to move to the left 10 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and put a new decimal point. And everywhere that there's a gap, we just put a 0 for each gap. And I like to put one more 0 out in front. So this is how to convert between scientific notation and a decimal number. So we started with scientific notation, and we just converted that into a decimal number. So because we moved this point is no longer there. Okay, let's look at this next one. So 1.495978707 times 10 to the 11th. So here you'll notice that our exponent b is a positive 11. So because this exponent is positive, we're going to move the decimal point to the right. And we're going to move it 11 times to the right. So we've got 1.495978707. We're going to move it 11 decimal places to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. New decimal point. Get rid of that one. And we've got two gaps here, so we're going to put zeros as placeholders there. So converting this scientific notation number into a decimal, this is what we get. So let me rewrite it. 149,597,870700. And every 3 digits, we'll put a comma. So that's converting it into scientific notation. So why don't you look at this think, pair, share and give this a try. So I've got this part of the think, pair, share, and then this part is writing this answer, part A, write it in scientific notation on your calculator. So kind of taking the base of 10 and replacing it with E, and see if you get the correct answer there. Give that a try.